Broken object level BOLA authorization vulnerability is a critical security issue in the APIs that occurs when an application does not properly validate the access controls of a user. This vulnerability can enable attackers to access or modify data that they are not authorized to access. This report discusses the BOLA vulnerability in API and provides recommendation for mitigating this security risk. The BOLA vulnerability occurs when an API fails to enforce proper authorization checks, which allows an attacker to access or manipulate data beyond their authorized level of access. This vulnerability can occur when an API relies on an insecure access control. This vulnerability can occur when an API relies on an insecure access control mechanism such as object IDs, file names, or other identifiers that can be easily manipulated. This vulnerability can lead to severe consequences such as unauthorized modification or disclosure of sensitive data, as well as the theft of user credential or other valuable information. To mitigate the BOLA vulnerability, developers should implement robust access control mechanisms that properly validate user permissions and prevent unauthorized access. Here are some recommended practices. Implement role-based access control (RBAC). It is a widely used access control mechanism that assigns permission based on user roles. This method allows developers to define specific roles and permissions for each user, which reduces the risk of unauthorized access. Use strong object identifiers. Developers should use strong identifiers such as unique random identifiers rather than predictable or easily guessable object IDs or file names. This can prevent attackers from manipulating object level permissions and accessing unauthorized data. Regularly testing and auditing API can help detect and mitigate BOLA vulnerabilities. Developer can use penetration testing, vulnerability scanning, and code review to identify and fix security issues before they are exploited. Educate users. Educating users on the importance of secure access controls can help prevent BOLA vulnerabilities. Users should be trained to use strong password and two-factor authentication, avoid sharing credentials, and report suspicious activity to administrator. The BOLA vulnerability in API is a severe security issue that can take attacker to access or modify data that they are not authorized to access. Developers should implement a robust access control mechanism, use strong object identifiers, regularly test and audit APIs, and educate users to prevent this vulnerability. By following these recommendations, developers can help ensure the security and integrity of their API and prevent unauthorized access to sensitive data. Here, in the application, CVS CareTrack is an online prescription benefit management (PBM) and mail order pharmacy service. Alice, the CTO of CVS CareTrack, has engaged a cybersecurity consultant Bob to perform regular penetration tests against the CVS CareTrack platform. So, penetration testing, also called pen testing or ethical hacking, is the practice of testing a computer system, network, or web application to find security vulnerabilities that would be attacker could exploit. For testing purpose, CVS CareTrack IT team has configured Bob a single test account to access the CVS CareTrack application. Bob began his assessment by logging on to the CVS CareTrack website within the following test credentials. Attack surface mapping. Having successfully logged in, Bob begins his assessment by browsing through CBS CareTrack user interface menus and function to get a feel for the product and to further identify test scenario and develop security test cases. Bob notices the prescription tab and select it to view the available prescriptions. In the prescription tab, Bob is shown the list of prescription orders associated with Bob's account and the status prescription that has been filled, including the prescribed drug, the order number, and shipping address. Bob orders history further shows a single prescription order filled and successfully delivered to his address. Noticing that the order history page contains a number of options for displaying and filter orders. Bob decided to test this functionality to understand how order filters are implemented by the CBS Category application. To understand how CBS Category order filter interface communicate with the backend server, Bob intercepts the HTTP request generated by his browser using a web proxy. A web proxy, also known as HTTP proxy, is a software debugging tool that enables web developer to view and modify raw HTTP and HTTPS traffic between their machine and a remote web application. This may include HTTP, HTTPS request and response data, request variables, parameters, headers, etc. Upon clicking the All Filter button, the application generates a HTTP GET request to the /API /user ID /orders resource. The request body further sends a filter parameter which is set to the value all. Now we have to analyze the response. Bob continues his investigation analyzing the HTTP response provided by the web server. Analyzing the HTTP response, Bob notices that the server responds with an array of order associated with the current user. Additionally, the response contains personal information about the user. Before you continue the testing, let's further analyze how Bob's HTTP GET request is handled by the CVS Catering application to filter prescription order associated with his account. CVS Cater developer have created the getOrders method to retrieve users' orders. The method takes an input parameter user ID which represents the ID of the current user and respond with the list of order associated with the user. Additionally, it adds user details to the response. The response object is then sent back to the user. Now I have to modify the request. Having analyzed the GET request, Bob attempts to modify the user ID parameter by changing its value from 4673920 to 4673921. Keep an eye on the code window as you modify the user ID parameter. Interesting, by simply changing the user value parameter in the GET request, Bob had received a totally different HTTP response. Whoa. It looks like the server just provided Bob with a list of orders and user detail of a completely different user, in this case Alice. The information further contains Alice's detail including sensitive information such as her medical prescription, information and shipping address. To further understand the root cause of this vulnerability, let's once again take a look at the source code used for providing the data about orders. The vulnerability exploited by Bob is also known as broken object level authorization attack, in which a malicious user gains access to a resource belonging to another user due to the lack of proper authorization checks. This attack can potentially occur in any application feature where untrusted parameters value are passed to the application without performing adequate authentication and authorization checks. The getOrder method is used to retrieve the orders of a specific user. The method takes an input parameter user ID which represents the ID of the current user and responds with a list of order associated with the user. However, notice that there is no authorization check present in the getOrder method. It blindly trusts the user ID request parameter without checking if the user actually has this ID. This allowed Bob to get unauthorized access to sensitive data information of another user. To effectively mitigate against broken object level authorization vulnerabilities, developers must ensure role-based access control checks are implemented to ensure that the user has the required privileges to access the requested resource. Product owners must further develop and maintain an access control policy that defines the appropriate access control permissions for all users and groups. This ensures that security requirements are described clearly to architects, designers, developers, and support teams, such as the application access control functionality is designed and implemented consistently. So let's see how the above best practices can be applied to our vulnerable code example to prevent broken object level authorization attack. In this mitigated example, we retrieved the user ID value from the secured HTTP session instead of replying or relying on the insecure get parameter. First, we use the get authentication method to retrieve the session. Next, we extract the user ID value from the session. If no user ID is present, that this means that the user is not authenticated. In this case, we respond with the HTTP 403 forbidden status. Otherwise, we pass the user ID value to the get order by user ID method, retrieving the orders of current user. These orders are then returned to the user via HTTP response body.